Okay, here's part two. And here's the three examples. And I wanted to go back because I just watched my own video. Sounds so terrible. Sorry. Okay, when I was watching my own video back, I noticed that I don't really know why, but on this one, I got a vertical compression because it's 0.25. But when I went back to teach it, I don't know why I said stretch, but it's going to be a compression. So if this is the parent function, it's going to look flatter. So it's going to press down towards the x-axis. So stretch would stretch away, but this is a compression problem, so it's going to press down because vertical compares to the x-axis, remember? So that's what that is. And so I think I was kind of, I don't know, I was kind of mumbling a little bit. So I'm going to reiterate. So the reason on cubic functions, if you do, here's my cubic function, my attempt. So instead of doing two transformations like pressing it and then stretching it, which it does a little confusing. That's why I always just combine it into one. Now, cube root on the other page, we're going to keep the problem simple. So this is inside. So it is way too difficult to sit there and take the cube root of 2 times whatever that is. I mean, it's possible, but in this class, we're not going to make you do the cube root of 2 and then multiply by something to get 1 over all transformations. So if I remember correctly from all the homework last year, that we kept it simple. So I'm kind of recanting a little bit. So we will do you can do horizontal stretch or compress on cube root when it's underneath there, but we're going to keep it simple. We're not going to put something else right there to do 2 in 1. So I take that back. We can do horizontal when it's inside the cube root function. So cube root function, you can have horizontal, but we'll keep it simple. Cubic function, we kind of stepped it up and did both inside and outside. And that's when I said that's too much. So let's just make it into one term and just do one overall transformation. Yeah, technically, are you doing 2 transformations? Yes. But to me, it's a little, it's more work. Well, actually, this is more work, but it makes more sense to the overall picture so you can visualize what the picture is doing. So that's that. So I would prefer on your homework when I grade it is that you combine this into one to do one overall transformation. Okay? Don't do 2 separate ones. Do one overall transformation because then you can understand what the graph is doing. So let's go back to these examples really quickly. So on this one, hopefully you taken the time to do that. So here it's a cubic function. So you have 3 things going on. You have a negative there, a +4, and a +2. So we'll start out up 2. All right, and so don't get tricked up here because what do you do with this right here? You go negative x plus 4 equals 0, right? So negative x equals 4, or you could say 4 equals x. Move to the other side. So 4 equals x, you're going right 4. So make sure you set it equal to 0. That's really important. So always set what's inside the parentheses or inside the radical symbol equal to 0 to make sure you're not missing out on any coefficient right there. Then here, if it's inside, the minus sign is inside the parentheses or inside the radical, that's going to reflect over where? So this right here, that negative means it's going to reflect over, hopefully you guys got this right, the y-axis. Hopefully you guys got that one. Okay, so if we were to tell what do the transformations do, the transformations would be, well, this is reflect over the y-axis, so that means you're going to multiply the x coordinate. Because think about it. If you're reflecting, like, I'm going to do a simple one. Like if here is a square root, if you're reflecting over the y, you're going this way. What's changing? Well, the x's are changing. The y is not. So that's why you're multiplying by the x coordinate, because the x's are changing. So therefore, your transformation would be negative x, because you're multiplying the x coordinate, right? 4, so plus 4 equals y plus 2. So that would be like what? 1, 1 would go to negative 1 plus 4 is what? 3? 3. Okay. Hopefully, any questions? I guess contact me in office hours. Okay. So this one, this is another cube root function. So the 4 is on the outside. So here, like I said, we're going to keep it simple. We won't give you 2 at one time when it's a cubic cube root function because it's hard to take the cube root of a number. So here it'd be what, 4, it's positive, it's greater than 1. So this is what, a vertical stretch of 4. Then that negative's inside the radical symbol. So that would be what, reflect over the y-axis. And then the last one would be what, down 1. So if I asked you, like, how do you transform a point? Transform a point would be what, negative x, then it'd be what, 4y minus 1. That would be your transformations. Oh, let me show you. Sorry. So like that. Gotta watch my camera. Okay, last one. Okay, so this is the one where I want you to make sure that you do it to combine it. So on a cubic function, I want you to combine find first term, because it makes more sense when you visualize what the graph is doing. So we can start out simple, or we can find the first term, either way. So let's find the first term. So it's going to be 0.25. And remember, this is like negative 4x times negative 4x times negative 4x. So it's going to be what? Negative 4, going to be what? Cubed, and then x cubed, right? Because you're going to cube each term. So it'd be 0.25, and then what is negative 4 cubed is what? Negative 64, then x cubed. A quarter times negative 64 is negative 16x cubed. Okay, so this is the first term. So the first term, that negative 16, you can tell what's going on here. So now it's kind of changing our mindset. So it's outside. So negative 16x cubed is all of this. So what are the transformations? Well, now I've changed it. So it's negative 16x cubed. So it's going to be reflect over x-axis. And then it's going to be what? Vertical stretch of 16, and then down 1. Down 1. Okay. That's a 1. The big one. Okay. So then what would be, how would you text the coordinates? The coordinates would be what? This is reflected over the x. That's your y. Vertical y. Okay, so it'd be x. And then negative 16y. And you could check you could map your points. Like, you can pick 1, 1 and map the points and then get your calculator and check it. That's what I would do. Okay. So if you're wondering why this is okay, because this question right here is this all right here is the same thing as this term because you're expanding it. That's what I'm doing, is expanding it. And then here you're probably wondering, well, if it's inside, it's reflect over what? The y. Here it's reflect over the x. And so some of you might be asking, well, if that's reflect over the y, reflect over the x, how can I do that? Well, let's think about it. I wish I had a pipe cleaner, but I don't. But let's see if this will help you very quickly see the visual. I'll try to. So this is a cubic function. Let's see if I can get it to work really fast. So here's a cubic function. So if you reflect over the x, that would be what? Reflect over the x, the graph would look like this, right? Reflect over the x. Well, if you reflect over the y, then I would pick it up and turn it like that. Oh, was it the same shape? It's the same thing because of the shape of the graph, because it's symmetrical. So like there is the parent function. That's the parent function. Reflect over x looks like this. Then if it's reflect over y, it's like this. So you can see on a cubic function, like this is y equals x cubed. When you reflect over x or reflect over y, it's the same shape. It's the same thing. So it doesn't matter. That's why it doesn't matter when I like expand it right here, that here it looks like reflect over the y, but when I expanded it, now the negative is outside, it's reflect over the x, but it's the overall transformation is the same. The thought process, like, hey, I'm going to reflect over x, or reflect over the y, the thought process is different, obviously, but the overall end of the shape is the same. That's why it's okay. That's why it's okay to expand this out. So this is what I want you to do on your homework. So hopefully you guys are watching the video, and I want you to combine this to get one overall vertical stretch or compress transformation. So on cubic functions, they all should be vertical stretch or compress, because I want you to take it out and expand it. We did it on this one, and we did it on this one. So make sure you expand your term, okay? Now the cube root, like here, cube root, we're going to keep it simple. It'll be either outside or it'll be inside. Here it's inside. And then what was the other one we did? Here, like it was only inside only. There's nothing out here. So cube root, we're going to keep it simple, but cube it, I want you to expand it. So hopefully that makes sense. Hopefully I've said it to make sense. All right. Well, that's my lesson for today. So hopefully I'll see you in office hours. Or if you have questions, let me know. Okay, bye.